All right, so remember yesterday when we were talking about the shell, remember the shell of your house, okay? And your biggest expense goes to heating and cooling all of that space and keeping the shell free from leaks, right? Do you remember that? Okay, so we're going to talk about conduction, convection, and radiation. We're going to go over that again, okay? All right, so up here on this worksheet, okay, so define conduction, okay? First of all, all of this is this is how heat is transferred, right?
What?
How heat energy is transferred. Sorry, so you can see it. I apologize, Brian. There you go.
What?
How heat energy is transferred. These three modes, okay? How heat energy is transferred. Write that down, guys. Is this a grade?
Yeah.
Yes. How heat energy is transferred.
Is it for
Hensley, there's your worksheet.
Oh, this?
Yes. Isn't this what I have, guys? Guys, I have the worksheet, right?
No, I can't see them.
Well, honey, I was just showing it to you.
Come on, Brian.
Okay. How heat energy is transferred. Okay, so there's three ways: conduction, convection, and radiation. So let's define them. I'll finish letting you write. Okay. Conduction is the easiest, right, to understand. How come?
Reasons.
Uh-huh. Why is conduction the easiest?
Because it's
Easiest to understand. Because why?
um,
Do you remember the Do you remember the example I gave yesterday?
no, that's a great question.
Okay, it is a great question. Okay, do you remember if I'm making hot cocoa? Yes, Lena. You can feel it. Remember the heat transfer? Remember when you heat your soup on the stove, or you have your hot cocoa and you stir it? Remember with your spoon and leave your spoon in there? Because it's direct contact, right? Shh, guys. Okay, so heat transfer by direct contact. Okay? And I'm going to say between materials. Okay, so, okay, can you still see that?
Kind of.
Okay? It's the first one. Heat transfer by direct contact between materials. So remember your windows on your house, right? Your doors. Okay?
Wait.
Okay.
So it's the one where it goes through the cracks of your house.
Do what, honey?
It goes through the cracks of your house to make the temperature that the house is.
Okay, direct contact. So I could feel it if I touched my windows.
Oh.
Okay? Okay, you touch windows right now, your glass, and it's what?
Cool.
It's really cold, right?
25 degrees cold.
Yeah, it's 25 degrees cold. Hello.
It's 20,000.
Okay.
Degrees. That's
Okay. All right. Now, so this is, okay. So, guys, if it says between materials, would these be solids?
Yes.
Yes. So you could have a solid, right? Because you're going to feel it, right? Right? Yes or no? Okay. Why I ask you that is because convection is between a gas or a liquid. Okay. Can you kind of remember a convection, a gas or liquid? No. That's not all. Mm-mm. Okay. All right.
A lot of people call you.
Hello. Good. Uh-huh. Oh, awesome. Awesome. Do I need to right now? Or? Okay, awesome. Yes, put mine because I need them desperately. So thank you. Okay, awesome. Thanks. Bye-bye. Okay. All right, define convection. Okay, so it happens between gas or liquids, and you have large volume, right? Large volume, okay? Large volume, I'm going to say of molecules, okay? So when I say molecules, atoms make up molecules. Remember atoms that we've talked about? Okay? So molecules moving, remember, from high pressure to low pressure, right?
Oh, that I was looking wrong.
High to low, okay? So moving really from warm to cold, right? And I'm going to say low pressure here. Okay. You can't see anything? You can't?
I can, but
Okay.
like right here.
I'm so sorry. Large volume of molecules moving from high to low pressure. Okay, remember high pressure means a lot of those molecules are hitting the sides of the walls. So if they're hitting, do they have a lot of energy?
Yeah.
Yes. So they're warm. Okay, so it'd be from warm to cool, right? Okay. So the oven that we talked about, convection, right? Okay. All right. Rate. Okay.
Why'd you say no?
We're not finished.
Okay.
So then just say, I'm not finished.
No.
Okay. Now radiation, again, you don't have to have a medium, okay? So remember, you have from a heat source, to surrounding area, and I'll move my hand here. Hang on. I know, just a minute, sweetheart. There you go. From heat source to surrounding area. Okay, so easy way to remember that, guys. Radiation. The sun radiates, right? The sun radiates heat. Is that an easy way to remember that, guys? Yes or no? I'm going to put the sun like that in the parentheses. Because the sun radiates, right? When I was a little girl, I always used to draw, and I still do as an adult. I draw my suns like this because I'm not a good artist.
Why does it look like a person? Is that little letter there? It's like a little person with that lip like a little
There. That's my sun. Okay?
That's your son? I didn't think you had kids.
I know. Okay, so that's my son. Okay. I know I don't draw very well. I'm sorry.
No, it's not that.
No, just go in the.
Okay.
No,
Okay.
don't draw like that no more.
All right.
I like that. I draw like that.
Okay. Liza, read the directions, please. Hey, shh. Read the directions, please.
Identify the method of heat transfer that takes place in each illustration. Some illustrations may show more than one form of heat transfer.
All right. Very good. Okay. All right. Do you guys have this?
Yeah.
Okay. So, do what? Okay. You have this written down, correct? Okay. So here. Okay. Let's go to here. Okay. So I've got a toaster. Okay. When you think about toasters, and I know hopefully you've never stuck anything there inside the toaster, right? But when you plug it in, turn it on, don't the coils heat up?
I'm stuck in a waffle.
Okay. Yes, Neely.
Oh, I was going to answer.
Okay, go for it, Neely. What do you think? Huh?
Convection?
Convection, you think? Okay, now can I ask you something else? Okay, guys, this is kind of tough, okay? So let's talk it through. Okay, so I have my coils heat up, so I understand why Neely said that, because like a stove, right, convection. But doesn't your toast lie directly on that?
Yeah.
so
Okay.
Conduction.
So what would it be?
Conduction.
It'd be conduction and radiation. Very good. That one's a tough one, isn't it? A lot of these are tough, guys. Aren't they? Aren't they?
Yes.
Okay.
I know.
and I'm going to say those, I'm going to say the coils here, right? Okay, the coils, because don't those heat up inside the toaster, guys? Okay.
I don't.
Okay.
Those little line things.
Huh?
In the toaster.
Yes, the little line things in the toaster. And they make little grids on your bread.
Yeah.
Mine actually touches my toast.
Yeah.
I have an old toaster. Okay. Yeah, and maybe the newer ones don't. That's right. Okay, number 2, a hair dryer. So you turn on the hair dryer and it heats this air right here. What do you think, Connor?
Convection.
All right, convection. Very good, Connor. Very good. Convection. Do you guys understand that?
Yep.
I think.
Okay. Okay. All right. Okay. Now, look at this iron. You've got 2 things going on. Shh. You've got steam going on. And then let's say we're ironing our clothes. So it's that. Okay, Lena. Which one, sweetheart? You said conduction, right? Mm-hmm. Which one, this or this? The bottom of it, right? Yes, very good. So this would be conduction, right? Because don't I directly iron my clothes, guys? Yes or no?
Yes.
Okay. So what do you think about the steam here? Uh-huh. Do what? Convection. Very good. Very good. Does that make sense? Yes? No?
Wait, well,
Okay. Number 4. Okay, we've got our fire, our bonfire, our little fire going. Campfire. What do you think?
wait, conduction.
Okay, Addison. You think so?
Because you can like feel it.
Okay, remember that we talked about the wiener roast yesterday? You guys were laughing at me because remember you cook wieners, you make s'mores. Okay, Asher.
Convection. Convection.
Oh, radiation. It's radiation.
Ooh, radiation. Radiation. Remember?
What?
It radiates heat. It radiates heat, remember?
I don't.
From the source. Okay?
If you put the wiener
The
on
fire
top of
radiates
the fire,
heat
and the
to you.
fire heats the wiener from the bar.
Yes.
Not me, the wiener.
Mhm.
Oh crap.
You guys don't eat hot dogs?
I do.
I love hot
I
dogs.
mean, I don't call it a hot dog. I call it a glizzy.
Okay. Okay. Whoa, whoa, whoa. Okay. Okay. This is. Shh. Okay. If you don't know what this is kind of like a space heater, kind of like a toaster. Okay.
Wait, like a waffle maker?
No.
No. Okay. So you plug in, and this is like a little space heater for your. Shh, guys. Hey. Okay. So if you don't know how this works, it heats up the coils. Okay. So it heats up the coils. So what do you think?
Radiation.
The coils are radiation. And then how does it heat my room?
Conviction.
Convection. Not conviction, convection, honey. Convection.
Convection.
Yes. Does that make sense? Good. Okay. Now this one should be an easy one. See, their son looks like my son.
Radiation.
Okay. Hensley, just laugh. What do you think? Bentley. Radiation.
Poor guy, he's just trying to build a sandcastle so he can
He's so murky, he's gonna cook it to bacon.
He's going to get a sunburn. Okay.
I mean, it's just why you don't have a hurt.
Okay.
Are these sunscreen? Oh, yeah.
All right.
Well, that's not a shirt, bro.
You guys ready? Okay. Number
I'm not gonna lie, number 7 was like the devil.
Okay,
Because he's a pitchfork.
Guys, he's got those little,
It looks like SpongeBob when he had the little things.
guys, hey. Okay, he's on a charcoal grill. Okay, Lena? Huh? Okay, he's cooking by direct contact, right?
Conviction?
direct contact. Don't you? Okay, just a minute, guys. Do you not lay the steaks or the hamburgers or wieners or whatever right on the grill?
Yes.
So that would be conduction. Okay. All right. Okay. But, okay, hang on. If I am using charcoal, how does the charcoal, and that's why I'm going to write charcoal, how does it heat? Radiation. Who said that? Yay, that's great.
Addie was actually saying it.
Good.
Oh, good job.
Okay. Does that make sense? Yes or no?
Yes.
Yes. Okay. All right.
The next one's conviction.
Okay, Brian, what about this oven? How does it bake?
Radiation.
Well, no, it heats up the coil thing.
Right.
Conduction.
No, guys. Okay, hang on.
Convection.
Convection. Very good.
I said it first.
I already technically.
Hey, you don't put your casseroles directly on those grids. You put them in a casserole dish. You put them in.
I thought you were
Hey, yes, Cameron.
But it heats up the pan and touches the cookies.
Okay, if it touches the cookies, then it's conduction on the bottom. Yes. If it was, are those cookies? It doesn't have cookies. Okay. Cameron asked a good question, or made a very good comment. If these were cookies, if they were, but it's a casserole dish, right? So the cookies on the bottom are directly on the cookie sheet, right? So that would be conduction, if those were cookies. But the oven itself is convection. Very good. Okay.
Radiation.
Okay, let's look at this. Okay, so I have a china cup here. Okay, Bentley, so what do you think? Tell me. Okay, whoa. Radiation, you think? What's going on here? Okay, Aaron. For what? If I touch the mug, the cup, yes, it would be conduction. Very good, very good. Now, yes, Lena, what about this steam up here? Convection, very good. You guys notice where I'm drawing the arrows? Is that important? Okay, because you guys understand you're going to have the backside to do, right?
Oh, what?
Yeah, there's 17 questions.
Okay.
They're so small.
Shh, guys. Okay. Okay, do you guys have that written down?
Conduction. No.
If you touch the cup, the china cup, yes. Good, very good. Okay, now I know these are kind of goofy. I didn't pick these paper. This paper was already made. I didn't pick the diagrams, okay? All right, so you guys understand what this is going on. Okay. All right, so this is a skillet. Shh, guys. So if I was camping or if I didn't have electricity like we talked about yesterday, I could have, this is a heat source, right? Where I have a little flame, like a little burner, okay? Like a candle. Yeah, like a candle. Very good, Connor. Thank you. And what I do, this is on stilts, makes it on a little stand, and then I put my skillet on here to cook my food. Okay, so what do you think this flame is?
Conviction.
Radiation.
Radiation, isn't it? The flame itself, right? Is that right? Okay. Okay. Yeah. Okay. Yeah. Now the pan, the skillet, when it heats up, that would be convection. Mm-hmm. Yeah, it's heating up. Heat up below, right? Okay. All right. Okay, so in case you don't know what this is a curling iron. Okay, and for those of you boys who don't know what that is, it's what you put in your hair, around your hair. Okay. Okay. Do I use one? Mm-mm. I have natural curly hair, but I use a hair dryer, and that's all I use. Yeah. Okay. Okay, you guys are going to have less time to work on your assignment on the back side. Okay. So, how do you curl your hair? You have to wrap it around. So, what do you think, Lena? Conduction. Conduction, right? Yeah. So, do you think that's kind of hard on hair?
Yes.
Yes. The curling irons can be hard on your hair because
if you leave it on for too long.
if you leave it on to learn, do you think you can burn your hair?
Yep.
Yes.
One time I
Okay.
burnt my hair.
And never do when your hair dry.
One time I burnt my hair.
Yes. Okay. Yes, Neely. Guys. Hey, you guys are burning up your own time. Yes, Neely.
Isn't that skin?
Where, hon?
Or is that hair?
Oh, that's hair. That's a little curly hair.
Oh.
Yeah, a little curly Q. Yes, Mr. Connor. Okay, Connor, let's go. What do you think?
Radiation.
Huh?
That is a charcoal or
Yeah, like if it's burning.
radiation.
Okay. So I'm going to write like that. Okay, so if you're burning pellets, that's radiation, right? Yeah, if you have a wood stove or burning wood, if you have a pellet stove or a wood stove, okay? My neighbors across the street have wood. My brother-in-law and sister-in-law burn little pellets. What?
Why do you have a wood stove that can catch on fire?
The thing is made out of metal, but you put wood
It's a
inside.
huge metal thing, okay? My brother-in-law and sister-in-law and my neighbor, it's not on carpet. They have a specially bricked area in their home that this sets on, okay? And then if you have a blower on it, okay? So I'm going to say this, okay? So let's say it has a blower on it like my brother-in-law and sister do. So how then would that heat?
That would be convection.
Convection, very good. Okay, so it heats up the room, okay? So let's say this is a wood stove or a pellet stove. Very good, Connor, you were right. Okay, and then if I have a blower, it's going to heat up around the house and the room.
Kind of looks like a charcoal heater.
Yeah, it does. Okay? A lot of people do that. Okay? All right. Okay. You guys understand that? Okay. So Kagan, please read the directions, sir.
In each of the following situations, identify the method of heat transfer taking place: conduction, convection, radiation. More than one process may be occurring.
Okay. All right. So go ahead. This first one is really easy. Want to do the first one together? Okay. Hensley, read that, ma'am.
Hot coffee is stirred with a spoon. The spoon gets hot due to convection.
Huh?
Conduction.
What, honey?
Conduction.
Conduction. Very good. Very good. Because isn't that direct contact? Okay. Now you guys can work on this together. Not together. Work on this quietly by yourself. Make sure your name is on it, please. Name, please. Thank you. Okay.